All right, so here's material. This would be a class 22 if we hadn't missed out some time. And I just want to go over a little bit of this topic here, cantilevered welded joints. I'll go through it quickly, and then I'll demonstrate something called weldments in SolidWorks, which is relatively something that I think will be useful for you to know about the existence of. All right, so I'll skip over that and come back to it. So what we have in welding, joints are here in the second part of the chapter, or the second class that we would have, is very similar to what we did with bolts in a distributed joint, where we have a primary and a secondary shear, where the primary is going to be because of this distribution of this force over to here, and then the secondary is because going to be due to a moment that's taking place, right? So what we do is we distribute the force, or this V, over the entire throat area, if you will, of this thing, and then we take the moment and we find a center of the and it's going to turn out to be like right up here, a center of this thing, and then we take an equivalent moment, place it about there, and then find out what the stress would be based like on a similar to, but not exactly, MC over I, but now it's going to be MR over J, and what R is going to be equal to is going to be the distance from here to here, right? And they're actually not showing it very well. So this double prime should be perpendicular to that, and together they're going to form that tau. And the J that we get for a particular section and the location about the center of the thing is going to be based on J is equal to 0.707 H, so that's the weld height, right? That's the leg height, right? Still, once again, that's this guy right here for the and that 707 is because we're assuming it comes through that section like that, but times a JU, and we get that from a table, right? So that's going to be JU, and it depends on what our welding condition would be. And so for this guy, that might look like, well, we have, like, if we had a bar like this right here, and we only welded one end to the thing, right? And so it's got a force right there. Or we might have a condition where we're cantilevered off here, and we have a coming in here, and we weld right here, and then on the underside of this. Or that's going to be one way that they could possibly use this, and we know that that's going to be the center of the thing. Or we could actually have the same thing that we've been used to here, where we have a weld like this and like that right there, like we had in the last class. Instead of being in tension, it's going to now be sort of a torsion, if you will, about its center. And well, you could tell that this thing, all we do is just rotate, and it's going to be all the same thing. And we find a JU, we find that JU based on these dimensions, and then use it inside here, and then put it inside there. And the same thing onto these right here. So here's the condition where we would now we'd have a weld right here and a weld right here, and so then the center would be right there. And then lastly, here's a condition, and they didn't do the square, or maybe they did and I just didn't include it in this like table, this excerpt, for some reason. Yeah, I think this table is longer, but you could see that this one forms like a little C, and we didn't put a weld on the back side like we did in there. So that's what you end up, you get the JUs. Ta-da. Let me double check the time, because class, let's see, I got 15 minutes. Okay. So here is, that's the one considered in torsion, right? So that what they mean is that like this, we're kind of putting a torque onto this, right? So maybe we could even call that a T if we wanted to, although they didn't down here. They call it an M. But it's like a TR over J. But now instead, if the weld is like up here, right? So we got to kind of picture what that looks like. If we picture the bar coming out right here, and we put the force onto here, the weld is going to be like right along there. And there's also a weld along the bottom right there that you can't see, right? So it ends up being, here's the little triangle of the weld on the top and the bottom. And obviously, this part right here is going to be in tension, and this part's going to be in compression. But we still pretend as if, and this is really weird, that this is the joint that it's going to be shearing along, right? That the shear stress that we're looking at is actually through the throat, because you'll notice that 0.707 shows up again. And now if we want to, now this one is easier to calculate the actual total stress than this one. This one you got to do, it's a little bit more difficult, not too much more difficult, but you got to make sure that you're combining this one correctly. So what we often have to do for the overall tau of this is break the tau double prime into an X direction and a Y direction. So it becomes, here you go, tau double prime X and tau double prime Y. So what we want to have here, we go tau double prime X squared, and then we have to add in the tau prime plus the tau double prime Y and make that squared, so we get the overall tau. Similar, but not different here because they're going to be perpendicular to each other, right? So one of the stresses is going that way and one of the shears is going that way. But interestingly enough, we're still using this 0.707 as part of that. But we do use the whole thing right here. We use the V over A. I'm sorry, I take that back. And we get that from a table. So you get the A. So there is the 0.707 is still in there. Here, we're going to use IU right here. Okay, so we got to be careful. We got to make sure that we do this. We don't use IU. We use I, which is 0.707 times H times IU, and we get the IU from right here, depending on what our section looks like. So you need to go to this and put them to find out what the individual stresses are, and then combine them together to figure out the stress. And this one is just because the tau prime is this way and the tau double prime is that way, so we don't have to do the same thing as this guy where we have to take and use the vector addition of the two things. But I'm not going to ask, because we don't have enough time for this class to do this one. I'm not going to cover this semester. But I might reuse this video in a later time. So just so you know. So I'm going to introduce quickly this thing called Weldments. It's a feature in SolidWorks, and it's very useful when you want to make a structure, and it's like a shortcut for making structures. There's a downside. You need to have loaded up in your library for the Weldments a bunch of different individual shapes, and that are above and beyond what comes in the default library, and that's a little bit of annoying on our computers. Because they have some restrictions as to where you can save stuff. So the different cross sections for the Weldments are saved under a directory that I'm not allowed to change on my computer at work. But let's take a look at this computer right here, or the thing right here. So introduction. So the brief thing that we do in SolidWorks, we make sure we turn on the Weldments, right? And it's underneath Insert Weldments, and they're right here. I'm not sure that they're always turned on, but you want to double check that they are as an add-on. And when it does that, it brings up a menu over here that we'll see in a second. And it always starts with this 3D. So you could also just make a 3D sketch, but they conveniently put the 3D sketch tool put right into this when the Weldments toolbar is activated. And then we insert these Weldments, and then we first draw the sketch. We pick a cross section, we select one of the lines, and then it shows as a ghost or a preview thing. It shows us the orientation of the section as it applies that line. And we could switch it around. We could rotate it. We could also pick, there's little key points in the cross section of these things, and you could choose different places for where the line that you drew in 3D, where that shows up in the cross section. So sometimes when you're making something, there's advantages to that. And you could do a number of pieces at the same time. I think that you're limited. You can't do more than one like total loop. All right, but you can add them in, and then you can start doing the trim, and you could trim them off so you can make a section. So I'll do a really quick demonstration, and I'll discard all of this stuff. So I'm already in a SolidWorks. I'll create a new part right here, and let's see if Weldments is activated. Yes, I have. You can see I have Weldments. The toolbar is already in there, but otherwise I would do the insert, and where'd you go? Weldments, right there. So you can insert Weldments would activate that toolbar. I don't know if this is an add-in or not, so you want to double check that you have it loaded in. I don't see it in here, so I'm not sure if it's in the student version. It should be. It's a very useful thing, especially this is the means that you actually activate the beam elements in SolidWorks simulation. So anyway, I started a 3D sketch, and these are really annoying to try to make. So you have to kind of be careful in how you make it, and you want to make it a little bit at a time. But you could see that as you're dragging this thing along here, you get the automatic. Okay, so I made this in the Z direction. I'm going to come up here, make it. I went in the Y direction here. Let me make this in the. I think they get an X direction. I'm going to make this one random, and then I'll make it connected around here. Okay. So it's trying to make a part here, but let's see where this one is. This should be along the X, right? It's not okay. It's putting the thing in there. Let's connect this guy right here. He should be along the Z. All right, and then I make this guy. By the way, if you rotate this thing, you can see it's all crazy looking all there. But I want to make this along the X-axis as well. Oh, it won't let me do it because I think it already has something in here, right? So let me delete that. And you got it does get very, very fussy here. Let me see. I don't want to insert a line. I don't want to insert a line. I want to rotate. Okay. Forgot how to rotate. I was using the rotating mouse buttons. Okay, so this one, I want this one along the Y. Is it going to let me do that one? It is going to let me do that in the Y. All right, so stop that. Use the right mouse controller here. So right here. Okay, so I think I screwed this up. Let's see. Double check why this is screwed up. All right, so this guy. I meant him to be, see, that's the problem. You draw the thing, and you think you have it right, and it's not. All right, so I'm screwing this all up. This guy, I wanted him to be along the Z. All right, so let me get rid of some of these to start with. All right. This guy, I intended him to be along the Z. All right, and I have him along the wrong side now. Alright, so can I move this guy around? Why can't I move you? Okay, so I wanted this guy to be along the X. Yep, that direction. And then, so I'm really making a great display. Alright, this one guy to be along the Y. Alright, so I'm really getting this thing screwy. Let's see, this is supposed to be in the negative Z over here. All right, and then this guy, I wanted to go upwards, and let's kind of drag him. I wanted him to be in the Z direction. I was making like sort of a lawn chair looking thing. Okay, it won't let me do it for some reason. All right, so I want this guy to be in the Z direction. Okay. And I want this guy to be in the X direction. Yeah. Oh, I know. I didn't put enough linkages in this. That's why. I should have put one more in there. I wasn't paying attention. I was kind of going on autopilot. Actually, no, that should have been okay. Damn you. All right, I'll get rid of him. All right, so I want this guy to be along the X direction. It's going to let me do it. Yeah, but... And then... No. I think I needed to make that along the Y direction. Let me change that to the Y direction. Yeah, okay. Yeah, that's what I wanted to do. And then this guy should be in the X direction. Boy, this is a great demo. I got 4 minutes till class starts. All right. So maybe I want to do some other bracing along here. All right. Good enough. And then I could put in some dimensions if I wanted to. I don't know what the dimensions are as part of this. I could constrain this, make it to whatever I wanted to. But you could see that there is a little bit of a difficulty in trying to get the stuff in 3D. It's a skill. I need to get better at it. Probably, especially if I'm a demo. But I make a 3D sketch, and now I go into Weldments, and I want to insert a weldment. All right, so weldment right here, and I just pick. I'm going to pick a loop that's like this right here. It's not letting me pick. I think I'll hold down. No. Okay, I see what I got to do. Okay, now I can do it. Sorry. All right, so look, the default was going to be pipe, right? And I should probably change it to metric because I'm in millimeters here anyway. And we could pick the kind of thing it is. So let's pick angle iron to start with, and let's pick a section of angle iron. Does this make any sense? Okay, yeah, that's interesting, right? And it's I picked a line right here. I can pick some more lines, and you can see what it's doing right there. It's even actually kind of making sort of a it's picking a particular orientation for this thing, right? And I can actually, and it's making corners. It's applying these corners. We can make them like a lap corner right here, or this other corner. You can see that we have these choices. And in here, you could also see that it's giving a preview of how it copes out in between things. And you could pick the joints a little separately. And then we could also, we could locate the profile. And what that'll do is we could like say, well, I would like it to be along this right here, because that's the way that I constructed my lines, right? I drew my original lines so that they were following along sort of the central piece. And then I could, maybe that's not true. A lot of times it'll default to this bottom corner right there and make the thing around that. So those are some choices that you have as part of this, and it won't let us do like a multi-loop, but we can add in another structural member. Like we could make this guy right in here, and it'd be really hard to make this. So maybe we want to make some kind of other one. Like we could make a round bar right in there, and we could pick a size. And we don't actually have that available. So we could pick a pipe, and let's pick the smallest one right in there. And you could see that it has made it right here, but obviously it's passing through there. So you need to use the trim feature right here. And there's a couple different trims, but you have like bodies to be trimmed right here, and then you have bodies that could trim, or you can go faces that can trim. And you can trim right here, and you can trim right there. It's actually giving me a messed up preview, so you have to play with it a little bit to see. But we could go bodies instead, So we go like this right here, and you can see that actually did a better job, or at least it looks like it did. So let's see if it trimmed the thing off. Yes, it did. Right, so you could see that it's trimmed the thing off, and you could also put little welding symbols inside here, like you could make it look like a weld bead. So we could pick it right here onto this edge, right in there, and all that's going to do, I don't think it's actually going to make a preview. Weld geometry. Okay, no, I see it right here. Let me see, clear this. I think you weld from here to here, and you can see there's the weld bead, okay? And we could, and you'll see that there's a call out right here, and you could adjust what that leg height is going to be, but then later on in the drawing section of this, you can have this will show up, right, or an option that you can have display this, and now you can designate. But it also can make a bill of materials and tell you what all the length is of a particular weld, so that you can do the budget for how much it's going to cost for manpower to be able to make this weld. So here was an abbreviated explanation of an introduction to weldments. It's a useful thing to be able to know how to do. And so with that, we will end this and then go to class. My life is so complicated.